Good morning. So today I'm going to kind of review this graphing quadratic equations in intercept form. You kind of watched the Khan Academy video 2 days ago, but I know some of you guys get confused with those. So then yesterday I had done a worksheet on this with myself going over it and going through the 8 different problems. So hopefully that helped to clarify a little bit. And today I'm going to do the same thing. I'm going to also attach this copy of these notes to the Google Classroom. So if you want to use it for studying purposes or for when you take the quiz. Graphing quadratic equations in intercept form. So really, it's just taking the factoring that we were doing in the last chapter, and we're just taking that information and putting it onto a graph. So intercept form of a quadratic is its factored form. So we spent weeks going over how to factor these quadratic equations and get them into these two little parentheses. So for example, if you had this equation here, right, x squared minus 10x plus 21, and you factored it, it would look like this, x minus 7 and x minus 3, because the two numbers that multiply to 21 that add to get 10 are 7 and 3, and it's a negative 10, so they're both negative. So we spent a couple weeks going over the factoring. So general rules for graphing quadratics of this form. Okay, so sometimes you have a GCF factored out on the outside. That's what that A is representing. And then X minus, and you're going to have two different numbers in there. So the P and the Q are just representing those two different numbers that you have being subtracted or added to those X's. So the first thing you're going to do is identify the X-intercepts and plot them. So that's what I had gone over on the worksheet yesterday. So remember we said I was going to use the zero product property. Okay, so we were using the zero product property, and we were setting up each of those factors and equaling them to 0 to solve for those two intercepts. And that's the same thing we did in the factoring chapter. After we found those two x-intercepts, then we could plot them on the graph right away if you wanted to, and then you're finding that vertex and that axis of symmetry. So the x-coordinate of the vertex, okay, is P plus Q over 2. So you're just taking those two numbers you get for your intercepts and you're averaging them out. So you're adding them up and dividing by 2. And remember I showed you on the graph yesterday, if you think about it, it was halfway between those two zeros or x-intercepts. Okay, so when we put those two x-intercepts on the graph, and I said you could even count the boxes on the grid to find like the middle, and that would be that x-coordinate of the vertex, which is also going to be your axis of symmetry. So then when you get that value for x, that middle, right, you plug it back into the original formula to get the y, and then that's your entire vertex point. And then we just said if it was a minimum or maximum when we graphed it. So here for step 3, it says find the y-intercept and reflect over the axis of symmetry. So you're just going to make sure your parabola is symmetrical. That's all. It says calculate f of 0 to find the y-intercept. That just means you're plugging in that x value to find the y. Then you can find one or two other points if needed and sketch your curve. Okay, so here's an example that's already done, or the information is there. I'm going to put it on the graph. So let's say, for example, this is our question, right? Graph f of x equals x minus 7 and x minus 3. So that's the one that they're kind of using up at the beginning. So the first thing we're going to do, step 1, is identify the x-intercepts and plot them. So how did I do this, right? So x minus 7 equals 0, and we solve it. And most of you guys probably figured out by now it's just going to be the opposite sign, right? So if this is x minus 7, it's going to be a positive 7. Then you do the other one here, x minus 3 equals 0, using that zero product property. X equals 3. So that's where we're getting these two points from. So the x-intercepts are 7, 0, and 3, 0. So we can go ahead and plot those on the graph. So 3, 0 is right here. 4, 5, 6, 7, 0 is going to be right here. So now, step 2, we're going to find the vertex and the axis of symmetry. So we're going to average out the 7 and the 3 that we just got for those intercepts. So you're going to add up 7 plus 3 and divide it by 2, and you're going to get a 5. So x equals 5. So that means that if you go to the 5, right, this here is your axis of symmetry. And that is a vertical line. So if you remember, vertical lines have undefined slopes and all that. And they have the equation x equals whatever number they cut through on the x-axis. Now that 5 can also be part of our vertex point. So what we need to do now is we want to find that vertex. We already know the first part of it is 5, because that point, that vertex of the parabola is going to be on that axis of symmetry, but we don't know where it's going to be. So we're going to take our original equation here, and we're going to substitute in the 5. So I'm going to just slide up here and do that. So if I put in a 5 minus 7 and then a 5 minus 3, I end up with a negative 2 times a positive 2, which is negative 4. So that tells me that my vertex is negative 4. And 5, negative 4. So I'm going over 1, 2, 3, 4, 5, and then down 1, 2, 3, 4. So it's right there. And so then you can draw your parabola. Now, this next step here, we didn't go over this really yesterday, but it is worthwhile to note. It says find the y-intercept. So that's going to be the point where the graph crosses the y-axis. And in order to do that, they're saying you're just going to substitute in the zeros for the x's. So if you want to know where is it going to cross on that axis, you would put in a 0 here and a 0 here, and you would get 21. So you know that there's that point 0, 21, which is going to be way off our graph up here somewhere. And then that would be another point on our parabola. I'm not so worried about that y-axis point right now. If you can just get the vertex and the 2 intercepts, that's what we're looking for. And then, of course, I want you to be able to label that vertex as a minimum or a maximum. So they are just what they sound like. A maximum is something really high or a large value, so it'd be a positive. So if the highest point on your parabola is that vertex, so when the vertex goes this way, your vertex is a maximum. When it's way down at the bottom, that means it's a minimum. And that's what we're going to do there. Okay? So now let's go on. I have a couple examples here on the next page. Obviously, I stole this worksheet from somebody else. Okay, so let's take a look at example A. So again, it's already in this factored form, which is known as the intercept method, because when you have the factors, you know what the x-intercepts are. So for this one, you can then solve each of these, set them equal to 0, and get the x's. So you know the x-intercept is going to be, in this one, negative 2. So it's negative 2, 0. And then the other one, when you set that one equal to 0 and you use zero product property, it's going to be x equals 4. So then that's going to be 4, 0. So those are your 2 intercepts. Now the vertex and the axis of symmetry, you're going to get by finding the middle of these 2 values. So you have 2 options. So one, you can look on the graph after you plot them and just look and see what is the middle point between these 2 dots, right? So if I have a negative 2 and a positive 4, what's the middle? Positive 1. X would equal positive 1. And that would be the first part of your vertex. Now, if you can't tell from looking at the graph, then you just average out those 2 numbers. Negative 2 plus 4 divided by 2. That would give you 2 over 2, which is 1. So you're just averaging them out to find that x equals. That same x equals 1 is our axis of symmetry. It's also going to be the first half of the vertex point. And then to get the second half, we're going to put in that 1 for both of these x's. So I put a 1 here and I put a 1 here. 1 plus 2 is 3. And 1 minus 4 is -3. When I multiply those, I get -9. So that tells me my vertex is 1, -9. So if I go over to 1 and down, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's right here. Okay, and then finally the y-intercept. So if you're doing the y-intercept, instead of plugging in the 1 for those two x's like we did to find the vertex, you're going to plug in zeros, which is going to give you 2 times -4, which is -8. So it's going to be 0, -8. Now this time that is something we can actually plot on this graph. Last time it ran off the page. So 0, -8 is going to be right here. And then we can plot this point as well because they're symmetrical. And then there's my parabola. Okay, so let's take a look at the next example. So next example, this time we have a little 2 in the front, so that isn't going to affect the x-intercepts, but it will affect the vertex and the y-intercept, okay? So x-intercepts you're just looking at these two factors, right? So if you do x plus 3 equals 0, what are you getting for x? X equals -3, so that's one of your intercepts. And then the other one, x minus 1 equals 0, so we're solving that one, and we get x equals 1. Now, once you guys can do that without doing that work, once you could do that in your head, you're really just changing the signs on those, then you can just write them down. You don't have to do that work every time. I'm just doing it so people know where I'm getting that from. Now, the axis of symmetry, remember, we're averaging out those two numbers. So you can either do it visually by looking at these 2 points. So -3, 0 is here, 1, 0 is here. What's the middle? -1. So I know that my axis of symmetry is going to be x equals -1. If you can't tell from the graph, then just add up the 2 points and divide by 2, and that would also give you that -1. Then for your vertex, you know the first part of that ordered pair is -1. So then you go to your original and you put in the -1 for these two x's. So if I do 2 times -1 plus 3 times -1 minus 1, that's going to be 2 times -2, which is going to give me a -8. So now I know my vertex, which is -1, -1, 2, 3, 4, 5, 6, 7, 8. Okay, then finally we want the y-intercept. So the y-intercept, we would just be plugging in zeros for these x's and seeing what we get. So if I plug in zeros, I end up with 2 times 3 times -1, which is -6. So 0, -6 is that y-intercept. 1, 2, 3, 4, 5, 6. Wait, I think I counted wrong. Yeah, it's right there. And then because you have that axis of symmetry, 1, 2, 3, 4. You can also plot a point on the other side of the axis of symmetry from that one. And then there is your parabola. And of course, your vertex is a minimum here, right? It's a minimum. This one was also a minimum because they were the lowest points on the graph. Okay, so I'm going to do 2 more with you. We're going to take a look at C and D. And let's see if I can get a brighter color there. Okay, so my x-intercepts here, you can set these two factors equal to 0 and solve them using the zero product property. And you're going to end up with 2, 0 and -4, 0. So right away, I'm going to plot those. So +2, 0 would be here, and -4, 0 would be over here. And the middle of those, I can tell, is -1. So I know My axis of symmetry is x equals -1. Now, if you're not sure about that, again, like I said, you can average out the 2 and the -4. You add them up, divide by 2, and you get that -1 that way. That -1 is also the first part of your vertex. Now, to get the second part of your vertex, you're going to plug in that -1. So then you're going to have negative times -1 minus 2, -1 plus 4, and you're going to work that out. So you end up with a negative times -3 times +3, which is going to give you a +9. So I'm going to graph that vertex. -1, +9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I want to find my y-intercept. So remember the y-intercept, we're just plugging in the zeros for the x's, which would give me, I'll erase this work here. So if I plug in the zeros, I have negative times -2 times 4, which is going to give me a +8. So +8. So 0, 8 would be that point. So that's right here. And then I'm going to do one on the other side of the axis of symmetry. So this is what my parabola looks like. It is a maximum this time because it is the highest point on the graph. Okay, and so now we want to take a look at the last one. All right, so again, my x-intercepts are just based off of these two factors right here. So hopefully at this point, you can kind of see that the x-intercepts are going to be -2 and +4. And I'm going to go ahead and plot those on my graph. So -2 and +4. And then finding the middle, I can tell that my axis of symmetry is going to go through the middle of those 2 points, which is at x equals +1. And I could also get that from adding those 2 points up and dividing by 2, just averaging them out. So my vertex is going to be 1, something. So that's where I need to now work this out, plugging in that 1. So I'm going to have -1/2 times 1 plus 2, which is 3, times 1 minus 4, which is -3. So I end up with 9/2, which is 4.5. So 1 and 4.5, so I'm going to go up 1, 2, 3, 4.5 boxes. Now to find my y-intercept, you're plugging in 0 for these two x's. So this time, when I plug in the zeros, I have -1/2, and then this is going to be a 2 times a -4. So that ends up being +4. So 0, 4 is my y-intercept, which is right there. And then on the other side of the axis of symmetry, I can do a corresponding point, and my parabola goes like this. So my vertex is a maximum. And another thing just to remember, whenever that a value, so here my a value is a negative, that's why the parabola opened down. Same thing on example C. So that's why we had a maximum point, because the parabola was sort of making that sad face or that frown face. And then, and then for A and B, these were positive A values. There's nothing there, which is a +1. This one was a +2, which is why the parabolas opened up and looked more like a happy face curve. All right, so hopefully this information helps you kind of iron out how to graph these quadratics in intercept form. Remember, intercept form is just the factored form. So we learned factoring in the last chapter. We did a lot of practice with factoring. Now we're just taking those answers and putting them on the graph. If you need any help, reach out to myself or Mr. K. There will be a meetup tomorrow. Well, today actually at 10:30. Or you can always send us a message on Remind. That's probably the quickest way to get in touch with us. Email, sometimes there's so many, it's hard to sift through them all, and I don't get to them immediately. So Remind, usually I can get back to you right away. And that's it. I will post a short quiz today that will be due by the end of the day Monday. So please, reach out if you need any help, and have a nice weekend. Bye.